Hey guys, this is a lesson for finding least common multiple of two whole numbers. Last session, we were looking at greatest common factor, which we're looking at two numbers that can multiply together to create a product. Here we're looking at multiples, which means we're counting by a number, like counting on, for example, 2, 4, 6, 8, 10, and so forth. Okay? Peso is just driving me nuts today, guys. He keeps jumping up while I'm trying to do this. Okay, so I'm going to show you two ways to be looking at least common multiple today. We're going to be doing a list of multiples, and then we're going to do my personal favorite, prime factorization. So much fun. So let's get ready. Hopefully you have a sheet of paper with 4 squares so that you can follow along with our lesson. We are first going to start with our start question. Which one does not belong? So when I look at these, I see I have 7, 14, 28, and 36. I see that 7 can be multiplied to make 14. 7 can be multiplied to make 28, but 7 cannot be multiplied to make 36. So that's kind of the thinking pattern that we want to be going on here. What can 7 be multiplied? What can we make it be multiplied by to make it into something else? Sorry, I'm having a hard time with words this video. All right. Number 1 in your first box. Morgan and Ann own North Country Sheep Farm. Morgan shears one herd of sheep every 6 months. Ann decides to shear another herd of sheep every 8 months to see if waiting longer results in higher quality wool. Both herds are sheared this month. How many months will Morgan and Ann shear their herds in the same month again? So our two multiples that we're looking at here are 6 and 8. So the first way that I'm going to show it to you, and the most common way that this is done, is by listing multiples. Oh, Peso's upset. All right, so we're going to start with 6, and then we're just going to count our multiples. So we're really just going to be counting by 6. So 6, 12, 18, 24, 30, 36, 42, 48. Okay, we'll stop there for now. And then we're going to go on with 8s, right? 8, 16, 24, 32, 40, 48. Peso, be quiet, please. Oh, I lost my train of thought. 2 more, 56. Okay, and I'm just going to stop there. Usually we can list up to about 10. We want to get probably up to 60 and up to 80, but I'm just going to stop here for time's sake. Okay, so what we're doing is we're going to look through our list of multiples and find out what is the smallest one that they have in common. Well, I can see here they don't have 12, no 16, but I do see that they share a 24. Okay, so my least common multiple in this case is 24. Okay, that's one way to do it. The other really cool way to do it is using prime factorization. So I'm just going to put a new sheet of paper here, and we're going to have 6 and 8. This is my absolute favorite, guys. It's so much fun. So what we're going to do here is we're going to start off by writing our factors of 6. And what we're going to do is we're going to try and find factors that are prime, that are going to be like the best number that will make it here. Just watch first so I can show you what I'm talking about. So 6, we know we can always do like 1 times 6, but really what we want to do is we want to get the prime factors here. So I'm going to multiply 2 times 3. And I know that 2 times 3 is going to make 6. I cannot reduce this 2 or this 3 anymore into smaller factors, so I'm going to leave that there. Peso, you are going crazy. He wants dinner. All right, you guys. So here I'm going to look over at 8. So I'm going to choose 2 times 4. Now, if I look at 2, 2 is as small as it's going to get. I can factor it out by 2 and 1, but really that's as small as we're going to get with it. 4, I know that I can make that a little bit smaller, right? So it's going to be 2 times 2. Okay. Now what I'm going to do is I'm going to write my factors for these numbers. So 6 is the same as 2 times 3. Okay. 8 is the same as 2 times 2 times 2. What we did here was we took 2 times 2 times 2. Now here's the really cool thing, you guys. This is so much fun, I promise. Okay, I'm going to change my marker here to a different color. All right, so what we're going to do is we're going to bring our first set down. We're going to bring this 2 times 3. Okay. Now I'm going to move over to my second set. And I'm going to see if there's any repeaters. So this one here, 2, that's repeated here, so I don't need to bring that one down. Then I'm going to go to the next one. Do I have any 3s? Nope. Now I can just bring what's left over. 2 times 2. Okay, we brought those down. Now what we're going to do is we're going to multiply this out, and we will have our least common multiple. 2 times 3 is 6. 6 times 2 is 12. 12 times 2, 24. So it's kind of the same thing that we did in the previous problem where we were listing multiples. But if you're someone who has a hard time recalling your multiples or skip counting, this is another way to go about solving it. I just think this is so fun because you're dealing with a lot of numbers here and it's a way to challenge your brain. So I would definitely challenge you guys to do it this way rather than listing the multiples. Or you can try both, like list the multiples, find your least common multiple, and then try the prime factorization to see if you get the same answer. Okay. Peso wants to sit on my lap right now. He keeps jumping up on me. All right. So first way that I showed you, listing multiples. Okay. Second way is we can do our prime factorization. Let's go ahead and look at number 2. This one I am going to do prime factorization. Okay, so it says Ria is buying plates and cups for a party. She wants the same number of each. Plates are sold in packs of 8. Cups are sold in packs of 12. What is the least number of plates and cups Ria can buy? So the one way that it's most commonly done is to list the multiples, but we're going to do prime factorization here. Okay, so I'm going to essentially pull apart this number by breaking it down by factors. So I'm going to do 2 times 4 here. And then you know that 4 can be broken down a little bit smaller into smaller factors, okay? Now I'm going to look at 12, and I know I could probably do 3 times 4. And 3 won't go any smaller, but 4 can be made into 2 times 2. Okay, so what we're going to do first is we're going to pull down the factors of 8, which is 2 times 2 times 2. Okay. And then I will pull down the factors of 12, which is 3 times 2 times 2. Okay. Now we're just going to combine them to make a prime factorization, or to make our least common multiple with the prime factorization. So first I'm going to start by writing down my red ones. Okay, so I have 2 times 2 times 2, that's the 8. Now what I need to do is I need to look through my list here, and I see I already have a 2, so I can mark that one out. So there's a 2 already here. We don't need that one. Okay, my next 2, already have one. Cross that out. Okay, and then my last 2, I don't have any more, so I can keep it. And then I just bring down this remaining factor, which is 3. So now I'm ready to find my least common multiple. 2 times 2 is 4. 4 times 2 is 8 times 3, 24. Yay. All right, looking at number 3, it says in problem 6. Let's not worry about that. In problem 2, numbers are all messed up here. Peso, he's hit my microphone. Sorry, guys. Suppose that Ria wants at least 40 plates and 40 cups. Could Ria buy exactly 40 plates and 40 cups? Explain. So we would want to think about these two numbers in terms of our problem here. So we had 8 and 12. Would it be possible for us to have her have 40 cups and 40 plates? So thinking about 8 and 12, when we're listing out our multiples, we have 8, 16, 24, 32, 40. So in the, I can't remember if this is plates or cups. Sorry, excuse me. Let's see. Plates are 8 cups. So these are plates and these are cups. So in the plates case, sure, we would get something that would equal out to 40. But if I'm going over to cups here, I have 12, 24, 36. Ooh, next one, 48. I wouldn't be able to have exactly 40 because this is too much. Okay. So no, Rhea could not buy them. Sorry, I'm just putting my answer out here. Okay, so no, Rhea couldn't buy at 40 perfectly because they do not have that same multiple. Our last problem that we're going to do here together is when Carlos goes to his favorite restaurant for lunch, he gets a sandwich and a smoothie. Okay, so stop being crazy. Thank you. The restaurant has 2 rewards programs. Buy 10 sandwiches and get 1 free sandwich, or buy 4 smoothies and get 1 free smoothie. How many times does Carlos need to buy a sandwich and a smoothie to get both of them for free on the same visit? Show your work. So we are going to be looking at 10 and 4 in this one. Okay. This one is when they're a little bit more doable numbers, sometimes counting by 10s and 4s, listing the multiple will get us the multiple a little bit easier. But the prime factorization, you guys, is so much fun. So let me show you. If we're just going to list it out, we have 10 and 4, right? So I have 10, 20, 30, 40, 50, and so on. Okay. 4, 8, 12, 16, 20, 24, 28, 32. Okay, so we're just going up a little bit. So our least common multiple, if I'm looking, what's the smallest number that they have in common? I can see that by listing multiples, I'll have 20. If we're going to do it as prime factorization, which to me, I'm telling you guys, is so much fun, we'll do 2 times 5 and 2 times 2. Okay, so these ones are pretty simple. So now what I need to do is just combine them. I have 2 times 5, 2 times 2. 2 times 5 is already there, so I already have a 2. Cross that out, and then just bring my extra 2 over. So 2 times 5 is 10, times 2, 20. Okay, Peso. You guys, I got to give Peso some love and attention here. So again, we end up with the same least common multiple. Both strategies are totally fine with which one you want to use. Listing multiples is totally fine. Using prime factorization is so much fun. You can do either one that works for you. All right, if you guys have any questions, please let me know.